This is mathheals.com, where you can find more links to math and computer science YouTube videos. And let's take a look at integration by substitution. Now, there's going to be different formulas we'll use in this section. Kind of a key, though, is what do you let u be? So what is u? Because we're going to be doing a U-substitution. Now I'm going to put two of the major ones here. If you have parentheses to a power, then whatever's inside your parentheses is your u. If you have a radical of some sort, then what's inside will be your u. Now beyond that, it goes back to our formulas over here. There's another one not listed here. Actually, let me go ahead and write it down. If you have something up on top, and that's really vague, isn't it? And then you got a fraction, you got a denominator. You let your denominator be u. So those are our three main ones, besides what's on the list that we'll be taking a look at. Other than that, all of these you see here, whatever follows cosine could be u, whatever follows cosecant squared could be u, and so forth. Yeah, make that a little bit bigger. There we go. Let's look at our problems. See how this works. So our first one, we have the integral 4x to the third square root of x to the fourth plus 2 dx. Well, remember we said if we have a radical, we let u equal to what's inside a radical. So u is going to equal to x to the fourth plus 2, what's inside a radical. Now we'll take the derivative of that. So the derivative of u with respect to x. And you should use this notation. Well, derivative of x to the fourth plus 2 gives us 4x to the third. Now we can separate these. So I can multiply both sides by dx. And we end up with 4x to the third dx. These dx's cancel over here. And we get du is equal to 4x to the third dx. Now it's a lot easier in showing these steps every time. We just take the derivative of u, just like normal, and then we just add dx on at the end. So we get du equals that. I'm not going to show these steps each time. The reason why you can put dx over here is for this reason. Now here, x to the fourth plus 2 matches that. 4x to the third, 4x to the third, dx, dx. Everything matches perfectly there. So we're going to replace what's in red here with u. So we'll have the square root of u. And this 4x to the third dx, what's underlined in blue, we're going to replace with du. And then I could rewrite this as u to the 1/2 power du. We always want to get it out of radical form. And now we got u to a power. Now our formula says we'll add 1 to our power. So 1/2 plus 1 and divide by your new power. And then plus c at the end. Well, 1/2 plus 1 is 3/2. So we got u to the 3/2 over 3/2 plus c. Now whenever you have a single fraction down denominator, you can flip it and multiply it times the top part. So we're going to have 2/3 u to the 3/2 plus c. Now the last thing we want to do is plug our u back in. Up here we said u is equal to x to the fourth plus 2. So we're going to have 2/3 x to the fourth plus 2 to the 3/2 power plus c. And that's our answer. Okay, let's look at another problem. Got the integral of cosine x over sine to the fourth x dx. Now keep in mind what this means. This is cosine over sine x to the fourth power. So if we come back up here, we said if we have parentheses to a power, we let u equal to what's inside the parentheses. Well, we got parentheses to a power down in the denominator. So we're going to let u equal to what's inside the parentheses. So u is equal to sine x. du, we're going to take derivative of that. Derivative of sine is cosine. And then we add on our dx. So this sine x here matches that. Is cosine, cosine, dx, dx. See how everything matches up? So we can do our substitution now. Replace sine x with u. So we've got 1 over u to the fourth. And cosine x dx gets replaced by du. Well, we can take the u to the fourth up on top. Becomes u to the negative 4 du. Add 1 to your power. So u to the negative 4 plus 1 over negative 4 plus 1. So add 1 to your power, divide by your new power, and then plus c. Well, negative 4 plus 1 is negative 3, so we got u to the negative 3 over negative 3 plus c. We want to take the u to the negative 3 downstairs. We don't want any negative exponents. So this will be 1 over negative 3 u to the positive 3 plus c. And last thing we need to do is plug our u back in. We said u is equal to sine. So we're going to have 1 over negative 3 sine to the third power x plus c. And that's our answer. Let's take a look at problem number 3. We've got the integral of x to the third minus 2 to the fourth power 3x squared dx. Again, our U-substitution. If we have parentheses to a power, we let u equal to what's inside the parentheses. So u is equal x to the third minus 2. Take derivative of it. Derivative of x to the third is 3x squared, and then we have to add on our dx. Well, the x to the third minus 2 matches that. 3x squared, dx, dx. So everything matches exactly. So we're going to replace this x to the third minus 2 with u. So we're going to have u to the fourth. And the 3x squared dx, we replace du. Add 1 to our power. So we got u to the fourth, or u to the 4 plus 1 over 4 plus 1. Add 1 to our power, divide by our new power. Plus c, which gives us u to the fifth over 5 plus c, which gives us 1/5 u to the fifth plus c. And now we want to plug our u back in. In this problem we said u is equal to x to the third minus 2, so we'll put in x to the third minus 2 for the u. Fifth power plus c. And that's our answer. This is integration by substitution, so I'm going to save that. Integration by substitution. Page 01.pdf. Okay, let's look at our next problem. Got the integral of x squared, and then x to the third plus 1 to the third power dx. Now again, whenever you have parentheses to a power, you always try to let u equal to what's inside the parentheses. So u is going to equal to x to the third plus 1. du, the derivative of that. Derivative of x to the third is 3x squared, and then we add on our dx. Well, we have our x to the third plus 1. Those match. We have our x squared. That matches. The dx matches. But it looks like we have an extra 3 in there. Well, it has to match exactly. Well, I'm going to put a 3 in there. So I got 3x squared, x to the third plus 1 to the third power, dx. Now you can probably imagine we just can't put a number in there. We'll offset it with a reciprocal out in front. Reciprocal is a fraction flipped. So put 3 here, I put 1 over 3 out in front. Because you think about going the other direction, 1/3 times 3, they cancel each other. Now this matches, x to the third plus 1. 3x squared, dx. So it matches perfectly. So then this becomes u to the third du. Again, I'm replacing the x to the third plus 1 with u, and I'm replacing the 3x squared dx with du. They don't have to be right next to each other, as you can see. You just have to have both of them in there. Well, add 1 to our power, divide by new power. So that gives us 1/4 u to the fourth plus c. 1/3 times 1/4 is 1/12, and u we said was x to the third plus 1. So plug that in. X to the third plus 1 to the fourth power plus c. And that's our answer. Let me grab a drink here. Number 5. Got the integral of t to the fourth, square root of t to the fifth plus 3 dt. We don't have to have x's. You can actually have any variable at all. Notice here we have a radical. And one of the things we said for u is try to let it equal to what's inside a radical. So u is equal to t to the fifth plus 3 du. Take derivative of that. That'd give us 5t to the fourth dt. Well, we have t to the fourth, we have a dt, but we don't have a 5 in there. So we'll put it in there. Put a 1/5 out in front to offset it. And we got 5t to the fourth. There you go. And then I'm going to go ahead and write this in rational exponent form. So it's t to the fifth plus 3 to the 1/2 dt. Okay, t to the fifth plus 3, t to the fifth plus 3. Those match. 5t to the fourth, 5t to the fourth, dt, dt. Those match. So this becomes 1/5, and we replace this to u. So this is u to the 1/2. And we replace 5t to the fourth dt with du. Well, add 1 to our power. So we've got 1/2 plus 1. Divide by our new power. So 1/2 plus 1 plus c. 1/2 plus 1 is 3/2. So we're going to have 1/5 times u to the 3/2 over 3/2 plus c. Remember, if you have a single fraction down in your denominator, you flip it and multiply it times your top part. So we got 1/5 times 2/3 u to the 3/2 plus c. 1 times 2 is 2, 5 times 3 is 15, and u we said was t to the fifth plus 3. So we got t to the fifth plus 3 to the 3/2 power plus c. And that's our answer. Okay, let's look at this one. We got x squared, and we got 5x to the third minus 3 to the second power dx. Well, with our U-substitution, I said if we have parentheses to a power, try to let u equal to what's inside the parentheses. So u is going to equal to 5x to the third minus 3 du, the derivative of that. Derivative of 5x to the third is 15x squared, and we add on our dx. Well, we have the x squared, we have the dx, but we don't have the 15. So we'll put a 1 over 15 out in front, and then we'll put a 15 inside. Okay, so now the 5x to the third minus 3 matches that. The 15x squared, dx, dx. Those all match. So this becomes 1/15 integral of 1 over u squared du. Now remember, if we have u squared down in the denominator, we can take it up on top, and the sign of the exponent changes, so it becomes u to the negative 2 du. Add 1 to our power, divide by our new power. So we got u to the negative 2 plus 1 over negative 2 plus 1 plus c. Gives us 1/15 times negative 2 plus 1 is negative 1, and same thing here, plus c. Now I'll merge this into a single fraction. So I got a negative downstairs, I got negative 15, and I'll take the u to the negative 1 power down to the denominator, becomes u to the positive 1, plus c. Now this negative I could put up on top if I want, so I got negative 1 over 15 times u, and u we said was 5x to the third minus 3. So 5x to the third minus 3, and then plus c. And that's our answer. Do I got room for this? I may not have room. Let me go ahead and save that. Okay, so we got the integral of x to the third minus 1 over 5x to the third dx. Well, U-substitution. We got parentheses to a power. So I try to let u equal to 5x. Now the derivative of that, du, would be 5 dx, which doesn't seem to match with what I have in my problem. I could put the 5 inside, as we saw, but then I got that x to the third over there. This one actually isn't a U-substitution. We can rewrite this. That's x to the third minus 1 over, and we take the 5 to the third power, which is 125, and x to the third power, which is x to the third dx. So that gives us x to the third. I can take that negative 125 separate from this x to the third. This x to the third will take up on top, and it becomes x to the negative 3 dx. So again, I just kept the negative 1 over 125 there, and I took the x to the third up on top, became x to negative 3. Well, now we're ready to add 1 to our power, divide by our new power. So x to the 3 plus 1 over 3 plus 1 minus 125 times x to the negative 3 plus 1 over negative 3 plus 1 plus c, which gives us 1/4 x to the fourth minus 1 over 125 times negative 3 plus 1 is negative 2. So we got x to negative 2 over negative 2 plus c. So we've got 1/4 x to the fourth. Negative times a negative is positive, and 125 times 2 gives us, this is positive, gives us 250, and we'll take the x to negative 2 back down to the denominator, becomes x to positive 2, and we've got a 1 there, plus c. And that's our answer. Let me open my window here. My wife has the heat on. It's killing me. Okay. Get the integral of x minus 3x to the third over square root or cube root of x dx. Now, if I try to start letting u equal to, you never let u equal to x, by the way. But we have a radical, so I'd let u equal to what's inside a radical, that wouldn't work. If I let u equal to the cube root of x, that wouldn't work. No U-substitution appears to work, but notice we have a single item down here in our denominator. You could have a single term, a single radical, a single trig function. You got a single item. If you have that, you can split them into separate fractions. So I'll put the x over the cube root of x minus 3x to the third over cube root of x dx. Well, this is x to the first power. Cube root of x, that's x to 1/3 minus 3x to the third over the cube root of x, which is x to 1/3 dx. Now, if you have x to a power over x to a power, you subtract the exponents. 1 minus 1/3 gives us 2/3, so we're going to have x to the 2/3 minus 3. And here we got 3. 3 minus 1/3 gives us 8/3. So we're going to have x to the 8/3 like that dx. Well, I didn't have to do a U-substitution. They're both x to a power now, so we'll add 1 to our power. So we've got x to the 2/3 plus 1 over 2/3 plus 1 minus 3 times x. Add 1 to your power, divide by your new power. So we got 8/3 plus 1 over 8/3 plus 1 plus c. Well, this gives us x to the 5/3 over 5/3 minus 3. X 8/3 plus 1 gives us 11/3. So we got x to 11/3 over 11/3 plus c. Now remember, if you have a single fraction down your denominator, you want to flip it and multiply it times your top part. So we're going to have 3/5 x to the 5/3 minus 3 times 3 over 11 x to the 11/3 plus c. I can do a little bit of simplifying there. I got 3/5 x to the 5/3 minus 3 times 3 is 9, so we got 9/11 x to the 11/3 plus c. And that's our answer. Now in this one, we want to solve the differential equation. So we're given dy dx is equal to x plus 2 over the cube root, or square root, sorry, x squared plus 4x plus 5. Well, to go backwards, to find y, we're going to take the integral of dy dx. That's how you solve that differential equation. That's going to be the integral of x plus 2. And I'm going to go ahead and rewrite this square root as the 1/2 power. So we're going to have x squared plus 4x plus 5 to the 1/2 power dx. Now this is U-substitution. We'll let u equal to, we got parentheses to a power, so we'll let u equal to x squared plus 4x plus 5. Now keep in mind, whether it's parentheses to a power or a radical, the u is the same. So they're actually one and the same. So derivative of that would give us 2x plus 4 dx, which doesn't quite match what we have up on top, but if we factor a 2 out of here, that gives us 2 times x plus 2 dx. Well, we have the 2 in there, but we don't have, or we have the x plus 2, but we don't have a 2. So we'll put a 2 in there. Offset it with a 1/2 out in front. So we got 2 times x plus 2 over x squared plus 4x plus 5 to the 1/2 power dx. Now this x squared plus 4x plus 5 matches this. The 2x plus 2 matches those. The dx matches that. So everything matches perfectly. So this becomes 1/2 the integral of 1 over u to the 1/2 du. Now we don't want u to the power down in the denominator, so we'll take it up on top, and we get 1/2 the integral of u to the negative 1/2 du. Add 1 to our power, so we're going to have negative 1/2 plus 1, and divide by our new power. So negative 1/2 plus 1, plus c. Well, negative 1/2 plus 1 is a positive 1/2, so we got u to the 1/2 over 1/2 plus c. Now, since I have a 1/2 here and a 1/2 here, those are going to cancel. And we got u to the 1/2 plus c. Now, up originally we said u was x squared plus 4x plus 5, so we'll put that in now. So x squared plus 4x plus 5 to the 1/2 power plus c. Now we could switch that back to square root form if we wanted to, but that's fine for your answer. Go ahead and save that. There we go. Okay. I'll go ahead and grab a drink here. Number 10. Got the integral of 2x sine of x squared dx. Now our formulas. If I come down here for looking for the one with sine, here's sine, says sine u. That tells us we set what follows sine equal to u. So we're going to set u is equal to x squared. Du, the derivative of x squared is 2x, and then we put on the dx. So this x squared matches with that. 2x, 2x, dx, dx. So everything matches. So this is going to become the integral of sine u du. Now the integral of sine u du, see how it matches exactly now? The integral of that is negative cosine u. So we're going to have negative cosine u plus c. And u we said was x squared, so we're going to have negative cosine of x squared plus c. And that's our answer. Okay, let's look at this one. Got the integral of negative 14 x e to the negative 7x squared plus 3 dx. E to a power. E to a power. That's our fifth one here. See how we have the integral of e to the u? So if you have e to a power, you try to let the power equal to u. So our exponent, we're going to have u is equal to negative 7x squared plus 3. Take derivative of that. Derivative of negative 7x squared is negative 14x. And then we have to tack on our dx. So this negative 7x to the third plus 3 matches with this. The negative 14x, dx, dx. So everything matches. This becomes the integral of e to the u du, which is easy. The integral of e to the u is e to the u plus c. So this is going to be e to the u plus c, and u up above we said was negative 7x squared plus 3. So we're going to have e to the negative 7x squared plus 3 plus c. And that's our answer. Okay. Got the integral of x sine x squared minus 3 cosine of x squared minus 3 dx. Now this one really doesn't fit very well with our ones we've been looking at. You know, if I try to let u equal to what's inside the parentheses, u is equal to x squared minus 3, du would be 2x dx, which then we have some extra information here. So what we're going to actually do is if the standard things to try fail, then you try some non-standard. Maybe we'll let u equal to sine x squared minus 3. If we do, the derivative of sine is cosine, so we've got cosine of x squared minus 3 times the derivative with respect to x of x squared minus 3 dx. So again, this is the chain rule. The derivative of sine is cosine times the derivative of what's inside the parentheses, and then you put your dx on. Well, the derivative of x squared minus 3 is 2x cosine of x squared minus 3 dx. Well, the some of this we have the cosine, we have the dx, we have the x, but we don't have a 2. Well, that's easy enough. We'll put a 1/2 out in front and put a 2 inside. So let's see what we're given. Sine of x squared minus 3, sine of x squared minus 3. So that's going to be replaced. 2x, 2x, cosine x squared minus 3, cosine x squared minus 3, dx, dx. So everything matches. So this will become integral of u. We replace sine x squared minus 3 with u. And then all the rest of this becomes du. Add 1 to our power, divide by our new power, plus c, which gives us 1/4 u squared plus c. And u we just said was sine of x squared plus x squared minus 3. So sine of x squared minus 3 to the second power plus c, which gives us 1/4 sine squared x squared minus 3 plus c. And that's our answer. Let's take a look at this one. Got the integral of the cube root of tan x secant squared x dx. First off, we said if we have a radical, let u equal to what's inside the radical. So let's do that. U is equal to tangent x. Don't know if it's going to go anywhere. Now the derivative of tangent is secant squared. Somewhere. Derivative of tangent is secant squared. So this du is equal to secant squared x dx. That matches this. Secant squared dx, secant squared dx. So that all matches. So this will become the integral of the cube root of u du. And we'll rewrite the cube root of u as u to the 1/3 du. Add 1 to our power, divide by our new power, plus c. Well, 1/3 plus 1 gives us 4/3, so we're going to have u to the 4/3 over 4/3 plus c. And remember, if you have a single fraction downstairs, you can flip it and multiply it times the top part. So that gives us 3/4 u to the 4/3 plus c. And last thing is we want to plug our u back in. U we said was tangent x. So we're going to have 3/4 tangent x to the 4/3 plus c. And that's our answer. Go ahead and save that. And we'll grab a drink. We'll take a look at the next one. Okay, we got the integral of cosine x over sine to the fourth x dx. We looked at one, I think our second problem was either real close to this or almost exactly like. But the sine to the fourth, I can rewrite as sine x to the fourth power, dx. Now our u-substitution. If we have parentheses to a power, you let u equal to what's inside the parentheses. So we let u equal to sine x. The derivative of sine is cosine x, and then we put our dx on. So now everything matches. Sine matches. The cosine dx all match. So we can do our u substitution. This becomes the integral of 1 over u to the fourth du, which gives us the integral of u to the negative 4 du. Remember, if you have a negative number on a bottom, or you have u to a power on the bottom, you can take it up on top, becomes negative. I'm about ready to fall asleep here. Add 1 to our power, so we got u to the negative 4 plus 1 over negative 4 plus 1 plus c, which gives us u negative 4 plus 1 is negative 3 over negative 3 plus c. Take that u to the negative 3 back downstairs. So we got 1 over negative 3 u to the third plus c. And plug our u equals back in now. We said u is equal to sine x, so we're going to have 1 over negative 3 sine to the third power plus c. And that's our answer. Okay, let's look at this one. Got the integral of e to the 3x plus 4e to the x plus 1 over e to the x dx. Well, if we try to let u equal to various things, it won't work. This is not actually a u substitution. Notice how we have a single item down in our denominator, e to a power. So I'm going to split this into separate fractions. So I'm going to have e to the 3x over e to the x plus 4e to the x over e to the x plus 1 over e to the x dx. Now if you have e to a power over e to a power, you subtract the exponents. 3x minus x gives us 2x, so we're going to have e to the 2x. These e to the x's cancel, and we've got plus 4. And this e to the x will take up on top and becomes e to the negative x dx. Now we can split these into separate integrals. So we're going to have the integral of e to the 2x dx plus the integral of 4 dx plus the integral of e to the negative x dx. Well, this first one, this is a u substitution. We'll let u equal to 2x. du will be 2 dx. So we need a 2 inside. We'll offset with the 1/2 out in front. So we've got 2e to the 2x dx. Here's 2x. Here's 2x. 2 dx dx. Well, this one, the integral of 4, gives us 4x. And this one, this is another u substitution, but instead of using u, I'll use w. So we got w is equal to negative x, then dw. The derivative of negative x is negative 1, or negative dx. So we'll put a negative in front of the e to the negative x, and we'll put a negative out in front to offset it. So we got negative, then negative e to the negative x dx. So again, we're replacing the negative x here with w. The negative dx. Negative dx. That's going to get replaced. Okay. So we've got 1/2, and then the integral of e to the u du plus 4x minus, then the integral of e to the u e to the w, dw. Well, the integral of e to the u is e to the u plus 4x minus the integral of e to the w is e to the w, and then we have to put a plus c on the very end. Well, we said u was 2x, so we're going to have 1/2 e to the 2x plus 4x minus e, and w we said was negative x, then plus c. And that's our answer. So let's go ahead and save that. Okay, and let's find our next one. This one's kind of an easy one. Got the integral of natural log of e to the 3x plus 4 dx. Well, if we have natural log ln, our base is e. Now remember, if your base matches the number that follows it, then the log and those e's are going to cancel. So those ln and the e's are going to cancel. And we're going to be left with the 3x plus 4 dx. So again, you use log properties to simplify this. Now we'll add 1 to our power, divide by our new power. So we've got 3/2 x squared plus 4 just becomes 4x, and then plus c. And that's our answer. Let's take a look at this one. Got the integral. Oh, wait a minute. We don't got an integral. Never mind. Got f prime is equal to 0.2 to the x over 3. 0 1/3. Okay, instructions say find an equation for the function f that has a given derivative and whose graph passes through the given point. Equation for the function f. So we want to find f. So to find f, we're going to go in reverse. Take the integral of our f prime of x, which is the integral of 0.2 x over 3 dx. Okay. We haven't seen this at all, but if I go back and look at my formulas, we have one up here, number 4, says the integral of a to the u. Now u can be anything, but a is a constant, it's a number. So this is going to be our a, and this is going to be our u. So u is equal to 1/3 x. Derivative of that. Derivative of 1/3 x is 1/3 dx. So we're going to put a 1/3 out in front, and we put a 3 out. We put a 1/3 inside, and we put a 3 out in front. I'm just hoping I make it. I'm just really sleepy here. I don't know why. dx. Okay. So the a's match. So that's good. And here we have 1/3 x, which is our exponent here. X over 3 is 1/3 x. We have 1/3 dx, 1/3 dx. So this becomes, we replace the 0.2 with a, so we got a to the u du. Now if I go look at this, a to a power, a to the u, that's 1 over natural log of a. 3 stays out in front, so 1 over natural log of a to the u, plus c, which gives us 3 over natural log of a, which was 0.2, times a, which was 0.2 to the u power, and u we said was x over 3, plus c. And that's our answer. Okay, I'm grabbing another drink here. And let's solve this differential equation. Let me go ahead and save this. Probably have room, but actually if I start up here I know I will. So 18. F double prime is equal to cosine x plus e to the 3x. Actually, let me start a new page. What am I doing? Okay. Okay, now let's look at it. We've got our second derivative equal to cosine x plus e to the 3x. Then we're given some initial conditions. F of 0 equal to 1/2, and f prime of 0 is equal to 1/3. And we want to solve this. Solving this differential equation means we want to end up with f of x equals something. So going back 1, f prime is going to equal to the integral of f double prime. So we'll have the integral of cosine x plus e to the 3x dx. And I could put these in separate integrals if I wanted. This would be the integral of cosine x dx plus the integral of e to the 3x dx. Now cosine is pretty easy, but this one here, this is a U-substitution. We'll let u equal to the power on e, and that comes from our fifth property here, e to the u. Whatever your power is, you let it be u. So then du, the derivative of that would be 3 dx. Well, the integral of cosine is sine. So we'll have sine x plus, we need a 3 inside, so we'll offset it with a 1/3 out in front. 3e to the 3x dx. So the 3x matches with the 3x there. 3 dx dx. All that matches. So we get sine x plus 1/3 e to the I'm going to skip steps. Let's try it again. This will become e to the u du. So that's going to equal to sine x plus 1/3 e to the u. The integral of e to the u is e to the u plus c. And then that gives us sine x plus 1/3 e, and u we said was 3x. So we got e to the 3x plus c. And that's our first derivative. Well, now we can find out what c is. Then one of the initial conditions said f prime of 0 is equal to 1/3. Notation-wise, whatever's inside the parentheses is your x. So they're telling you x is equal to 0. Number on the right side, this is going to be f prime. So they're telling us f prime is equal to 1/3. Well, we can plug those in now. The f prime is equal 1/3 sine of x, which is 0, so sine is 0, plus 1/3 e to the 3 times 0 plus c. Well, sine of 0 is 0, so it drops away. 3 times 0 is 0, e to the 0 is 1, so we got 1/3 equals 1/3 plus c, which implies c is equal to 0. So our first derivative now becomes f prime of x is equal to sine x plus 1/3 e to the 3x plus 0. Well, now we're ready to go back one more step. F of x is going to equal to the integral of f prime. So that's going to be the integral of sine x plus 1/3 e to the 3x dx. I can split these up into separate integrals. So this will be the integral of sine x dx plus 1/3 the integral of e to the 3x dx. Well, the integral of sine is negative cosine. So that's negative cosine plus 1/3. And we found this one up above. The integral of e to the 3x dx is going to be 1/3 e to the 3x plus c. Which gives us negative cosine x, 1/3 times 1/3 is 1/9, so plus 1/9 e to the 3x plus c. Well, if we go back to our initial condition, I guess it's up at, well, where is it at? Initial condition, we had f of 0 is equal to 1/2. What they're telling us here is what's inside the parentheses are x, so they're telling us x is equal to 0. And this other side is going to be f of x. So f of x equal to 1/2. Now specifically, it's f of 0. And if we were to plug 0 in for x, then it makes sense. But for purposes of actually working these, you can think of it as f of x. So f of x over here we replace with 1/2 equals negative cosine 0 plus 1/9 e to the 3 times 0 plus c. And then we want to solve for c. So got 1/2 equals, cosine of 0 is 1, so that's negative 1, plus 1/9. 3 times 0 is 0, e to the 0 is 1, plus c. Take those all over the left side, so we got 1/2 plus 1 minus 1/9 equals c. Which gives us 3/2 minus 1/9 equals c. Get a common denominator, which would be 18. Multiply the bottom part by 9, top part by 9. So 27/18 minus bottom part by 2, top part by 2 equals c. So we get 25/18, assuming no basic math error. So this one right here now becomes f of x is equal to negative cosine x plus 1/9 e to the 3x plus c, which was 25/18, assuming no basic math error. When I get as sleepy as I am now, I get kind of iffy. There we go. 7. And let's look at our next problem. We've got the integral of x square root of 3x plus 2 dx. And U-substitution, we got a radical, don't we? So we're going to let u equal to what's inside the radical. U is equal to 3x plus 2. du, derivative of that, derivative of 3x plus 2 would be 3, and then we add on a dx. Well, we can put the 3 inside, so that's not a big deal. The dx is there, so that's fine. This gets replaced by u, but we got an extra x in front. Well, what I can do is this u equals 3x plus 2, I can solve it for x. So I'll take 2 over to the left side, so we got u minus 2 equals 3x. Divide both sides by 3, and we get u minus 2 over 3 is equal to x. So now, this 3x plus 2 matches that. 3, we need the 3. Okay, well, we'll put a 1/3 out in front and put a 3 inside. Okay, so that matches there. du is 3 dx, so 3 dx matches. And then the x here matches the x here. So let's see what we have after we substitute that in. The x, we'll put in u minus 2 over 3 there. Then the square root of u, and then the 3 dx gets replaced by du. Now this 3 that's in the denominator here, I can put it out in front. So we're going to have 1/3 times 1/3. The integral of u minus 2, and square root of u is u to the 1/2 du. 1/3 times 1/3 is 1/9. And I could take this u to the 1/2 and multiply it through. So we'll take u to the 1/2 times u. That gives us u to the 3/2, 1 plus 1/2, minus 2 u to the 1/2. So we multiply it times a negative 2 also, du. Okay, so we'll add 1 to our power. So u to the 3/2 plus 1 over 3/2 plus 1, minus 2 u, add 1 to your power, 1/2 plus 1, divide by new power, 1/2 plus 1, plus c. Which gives us 1/9. 3/2 plus 1 gives us 5/2. So that's u to the 5/2 over 5/2, minus 2, and 1/2 plus 1 is 3/2. So we got u to the 3/2 over 3/2, plus c. Now if you have a single fraction downstairs, you can flip it and multiply it times your top. So that becomes 2/5 u to the 5/2 minus 2 times 2/3 u to the 3/2 plus c, which gives us 1/9, 2/5, and u we said was, what did you say u was? 3x plus 2, so we'll put that in. So 3x plus 2 to the 5/2 minus 2 times 2 is 4, so we've got 4/3, and plug in 3x plus 2 to the 3/2 plus c. Now it's possible to multiply the 1/9 in. If they do, then that gives us 2 over 45, 3x plus 2 to the 5/2 minus 4/27, 3x plus 2 to the positive 3/2 plus c. And that's our answer. So that one's not a typical U-substitution problem. Let's take a look at this one. Starting to wake up. Square root of x plus 2, then 4x plus 2 up on top, dx. Well, we got a radical. Whenever we have a radical, let u equal to what's inside the radical. So u is equal to x plus 2. The derivative of that, du, derivative of x is 1, so we have 1 dx or just dx. Well, again, that's handled, this is handled, but we got an extra x up here. So I'm going to come over this u is equal to x plus 2 and solve for x. I'll take 2 to the left side, so we got u minus 2 equals x. So this x plus 2 here is going to be replaced by u. The dx is going to be replaced by du. And then this x up here is going to be replaced by u minus 2. So let's see what we get. We got 4 times u minus 2 plus 2 over square root of u du. So 4 times u is 4u. 4 times negative 2 is negative 8 plus 2. And square root of u we rewrite as u to the 1/2 power du. Which gives us the integral of 4u minus 6 over u to the 1/2 du. Now notice we have a single item down in the denominator now, so we're going to split them up into separate fractions. So we're going to have 4u over u to the 1/2 minus 6 over u to the 1/2 du. Now this is u here is u to the 1st power. So we're going to have 4 u to a power over u to a power. You subtract the exponents. 1 minus 1/2 gives you 1/2. So we've got 4u to the 1/2 minus 6u to the negative 1/2. Again, whenever you have u to a power down in your denominator, you can take it up on top and the sign of the exponent changes. Well, now we're ready to add 1 to our power, divide by our new power. So we've got 4 times u to the 1/2 plus 1 over 1/2 plus 1 minus 6 times u to the negative 1/2 plus 1 over negative 1/2 plus 1 plus c. Add 1 to your power, divide by your new power. 1/2 plus 1 is 3/2, so we got u to the 3/2 over 3/2 minus 6 times negative 1/2 plus 1 is 1/2, so we got u to the 1/2 over 1/2 plus c. Again, if you have a single fraction down your denominator, flip it, multiply it times your top. So we've got 4 times 2 over 3, u to the 3/2, minus 6 times 2 over 1, u to the 1/2 plus c. 4 times 2 is 8, so we got 8/3, and we'll plug our u in. We said u is x plus 2 to the 3/2 power, minus 6 times 2 is 12, u, which was x plus 2 to the 1/2 plus c. And that's our answer. Go ahead and save that. Excuse me. And let's look at our next problem. This is finding a definite integral while using U-substitution. So it's going to go from 0 to 2 of x over the square root of 3 plus 4x squared dx. Well, to find our U-substitution, if you got a radical, you let u equal to what's inside the radical. So u is equal to 3 plus 4x squared. The derivative of that, 3 drops away. The derivative of 4x squared gives us 8x, and then we throw on our dx. So we need an 8 inside and a 1/8 out in front. So we've got 1/8, 0 to 2, and then we've got 8x there. Square root of 3 plus 4x squared dx. Okay, 3 plus 4x squared matches that. 8x, 8x, dx, dx. So everything matches. So this is going to become 1/8. And I'll put some x values here. This is x equals 0 and x is equal to 2. And we'll have 1 over the square root of u du. Which gives us 1/8 from x is equal to 0 to x is equal to 2. of 1 over u to the 1/2 du. We'll take the u to the 1/2 up on top. So we've got x equals 0 to x equals 2, and this becomes u to the negative 1/2 du. And now we're ready to find our interval. So we'll add 1 to our power. So we got u to the negative 1/2 plus 1, and divide by our new power. So negative 1/2 plus 1. And that'll go from x equals 0 to x equals 2. Now I put those x values there for a specific reason. That way I don't plug in the numbers too soon. And we'll see that in a second. Negative 1/2 plus 1 is 1/2. So we got u to the 1/2 over 1/2 from x equals 0 to x equals 2. Remember, if you have a single fraction down below, you flip it and multiply times the top. And actually, we can go ahead and put it outside the bracket. So 1 over 2 becomes 2 over 1. And we're left with u to the 1/2 here, which is the square root of u from x equals 0 to x equals 2. That gives us 2/8, which is 1/4. Now, I'd be tempted to plug these values in, but keep in mind, this is x equals, and this is u. So we have to plug our u back in first, whatever that was. Let's go look. U, we said, was 3 plus 4x squared. From x equals 0 to x equals 2. And now we're ready to plug those in. So I'll plug in my 2. So I'll have the square root of 3 plus 4 times 2 squared minus square root of 3 plus 4 times 0 squared. Fundamental theorem of calculus. So we get 1/4 times 2 squared is 4 times 4 is 16 plus 3 is 19. So we got square root of 19 minus 0 squared is 0 times 4 is 0, which leaves us square root of 3. And that's our answer. Now this is the way I like to do it. I like to do my U-substitution, simplify, then plug my u equals whatever back in, and then plug in my x values. Some people do it different. I like it this way because it kind of flows with our normal U-substitution. Some people, when they do the U-substitution up above, besides just switching the x's here, this is x equals 0 and this is x equals 2, our lower and upper limit. They take these and plug them in to this u equals 3. I'm still kind of out of it. Can't speak. So we'll plug him into u equals 3 plus 4x squared. So we'll put 0 in for x. So we've got u is equal to 3 plus 4 times 0 squared, which gives us u is equal to 3. And on this one, we'd get u is equal to 3 plus 4 times 2 squared. 2 squared is 4 times 4 is 16, plus 3 is 19. So when they get down to this spot right here, they'll write it this way. They'll do the 1/8, and this will be from u equals 3 to u is equal to 19 of 1 over square root of u du. Now the reason why they'll switch those is then when they get down to the point here where they got square root of u, you can just go ahead and plug in these numbers. Now really it does not save you any steps doing it one way or the other. And I like the first method because it just kind of flows with the way we've already been looking at for doing U substitution. I'll go ahead and save that. And let me grab a drink and we'll look at the next problem. Okay, so we got dy dx is equal to 5 plus x squared over 5x to the third plus 1 squared, then this point here. Okay, it says use differential equation in a given point to find the equation of the function. So we want to go backwards. We want to find y equals. Well, to find y equals, you're going to take the integral of our derivative. So the integral of dy dx, which will be the integral of 5 plus x squared over 5x to the third plus 1 squared dx. Now I can split those into separate integrals. So that'd be an integral of 5 dx plus the integral of x squared over 5x to the third plus 1 squared dx. Well, the integral of 5 just gives us 5x. And this is a U-substitution. If we let u equal to we got parentheses to a power, so we'll let u equal to what's inside the parentheses. So we got u is equal to 5x to the third plus 1. Du, the derivative of that would give us 15x squared dx. I have the x squared up there, but I don't have the 15. So I'll put a 1/15 out in front, and then I'll put in a 15x squared up on top. Squared dx. Okay. So we got y is equal to 5x plus 1 over 15. And we're ready to do our u substitution. So this becomes 1 over u squared du. We replace the 15x squared dx with du, and this we replace with u. So that's going to give us 5x plus 1 over 15, the integral of u to the negative 2 du. 5x plus 1 over 15. Add 1 to our power, so negative 2 plus 1, and divide by our new power. Plus c. Excuse me. So we got y is equal to 5x plus 1 over 15 times negative 2 plus 1 is negative 1. So we got u to the negative 1 over negative 1 plus c. Which gives us y is equal to 5x. This negative I can put up on top or out in front. So then 1 over 15. And I took this u to the negative 1 downstairs and become u to the positive 1 plus c. Well, now we're going to plug our u back in. So let's scroll up, see what u was. U, we said, was 5x to the third plus 1. So 5x to the third plus 1 plus c. Now they've given us a point. They're giving us 0, 1. Well, what they're giving us here is they're telling when x is equal to 0, y is equal to 1. So we can use those to help us solve for c. So I'll put 1 in for y, put 0 in for x. So we've got 5 times 0 minus 1 over 15. 5 times 0 to the third plus 1 plus c. So 5 times 0 is 0, that drops away, minus 1 over 0 to the third is 0, times 5 is 0, so that drops away, and we got 1. 15 times 1 is 15, plus c. Take that over, and we got 1 plus 1 over 15 is equal to c, which gives us 16/15 is equal to c. Which means the equation we're working with, this one right here, is now going to become, since we now know what c is, y is equal to 5x minus 1 over 15 times 5x to the third plus 1 plus c, which was 16/15. And that's our answer. Let me go ahead and save this. And let's look at our next problem. We got y is equal to cosine x plus sine 2x from 0 to pi over 2. And the instructions say find the area of the region. Well, let's first graph this. So I'm going to go here, make sure I'm in radians. So I'll press mode, down arrow to the third line, and if yours isn't selected, put your flashing cursor on radians and press enter one time. And then second mode to exit out. We'll press y equals, clear. We got cosine x plus sine 2x. Now I'm going to choose zoom, and I'll choose number 7 for Z trig. Now you set it back to zoom 6 for Z standard once you're done. Now this goes from negative 2 pi to 2 pi, so from 0 to pi, which is or 0 to pi over 2, 0 to pi over 2, you see it's above the x-axis. That's all we needed to verify. Which means, to work this problem, to find the area, that's going to equal to 0 to pi over 2 of cosine x plus sine 2x dx. Now I must put these into separate integrals. So this is going to go from 0 to pi over 2 cosine x dx plus 0 to pi over 2 sine 2x dx. Now the cosine x is fine. It's pretty straightforward. But this one we have to use a U-substitution on. We'll let u equal to 2x. Then du, the derivative of 2x is 2, and we have to add on a dx. Well, on this one, the integral of cosine is sine. This is 0 to pi over 2. Plus, we need a 2 inside, so I'll offset it with a 1/2 out in front. So then we got 2 sine 2x dx. Well, the 2x there matches that. 2 dx dx. So everything matches. Now here, I'll plug in pi over 2, so I got sine of pi over 2 minus sine of 0 plus 1/2, and this will be from x equals 0 to x equals pi over 2, and that becomes sine u du after we do our substitution. Now again, our goal is to get that to look like something in our table here, and we have an integral of sine u du. It's number 6. Okay, back to my first part. Sine of pi over 2 is 1, minus sine of 0, which is 0, plus 1/2. The integral of sine is negative cosine u from x equals 0 to x equals pi over 2. That 0 drops away, so we've got 1 plus, or actually, I'm lying to you. That negative we can put out in front, so we got 1 minus 1/2. And cosine of u, and we'll plug our u back in now. Up above we said u is equal to 2x, so we've got cosine 2x from 0 to pi over 2. Plug those in, and we're going to have cosine of 2 times pi over 2 minus cosine of 2 times 0. So 1 minus 1/2. These 2's cancel. I got cosine of pi, which is negative 1, minus 2 times 0 is 0, so I got cosine of 0, which is 1. Negative 1 is negative 2. Negative 1/2 times negative 2 gives me 1, so we got 1 plus 1, or 2 is our answer. Let me go ahead and save that. for that to blow up. So I'm going to bring up another. There we go. And let's look at our last problem. Now all this one says is use a graphing utility to evaluate the integral. So we're not going to do it by hand. X square root of x minus 2 dx. And this will probably give us an approximate. Sorry. There we go. Okay, so let's go to our TI3, TI4. I'll press y equals clear. Now I'm going to put in x square root, so I do second x squared, x minus 2, closing parentheses at the end if you want. TI3, TI4 doesn't need them at the very end. I'm going to press zoom and choose 6 for Z standard. Set it back to my standard viewing window. And then I'm going to do second trace, and I choose number 7, the one that looks like the integral. It's going to ask us for lower limit, which is 2, inner, upper limit, which is 4, inner. And that'll give us approximately 6.034. And that's our answer. So I'll go ahead and save that. Unfortunately, it won't give you the exact value, just give you an approximation. So unless they specifically ask for, usually you want the exact value. Approximation isn't good enough. There we go. And I'll get there eventually. Here we go. That's our last slide. So I'm going to go ahead and stop the recording.